Hello everyone! Today we are looking at an experiment we haven't seen in a while, a unique experiment, a closed ecosystem that is always illuminated. Let's see how this project started. So I put some water and sediment from a pond in a jar. It is lit during the day by natural light and lit at night by the LEDs. At the start of this experiment, the jar was home to loads of tubifex worms, aka boogie worms, as well as some copepods and some really tiny ostracods. The usual suspects so far. Also present was this non-blood-sucking leech, Erpopdella octoculata, which has one of the coolest animal names in Dutch ever, I think. We call it achtoogige bloedegel, which translates to eight-eyed blood hedgehog. After having seen no darkness for 2 weeks, the glass of the jar was covered with algae, which makes sense of course, as algae use light to photosynthesize and grow. More light means more growth. It's not always that simple, but more about that later. The water itself remained crystal clear, possibly due to the algae on the glass using all the nutrients and carbon dioxide, preventing single-celled algae from growing. After 2 weeks, an inhabitant we didn't see before showed its face, a bladder snail. The eight-eyed blood hedgehog seemed unfazed by the 2-week day. Another new jarling showed up, this small flatworm, which had made an intricate tunnel system. The copepods were doing fine as well. From the density of algae on the glass, you can tell where the LEDs were located. After 4 months, the jar looked like this. It seems that most multicellular algae, including the string algae on the glass, is gone. The water is now filled with unicellular algae, which tipped the scale somewhere in the last 4 months and now seem to be preventing multicellular algae from growing. At this point, the copepods and leeches seem to have disappeared, but the ostracods have been busy. There were just a few individuals at the start of the experiment, but they have reproduced so much that there's now a really large number of them. They have a ton to eat, that probably helps. The boogie worms were having a fabulous time in this never-ending disco party. Look, this one doesn't even stop dancing for a bathroom break, swinging poop around from its head. Awesome! The bladder snail has become more than one bladder snail. They also seem to be loving this environment with an abundance of food. This is the jar after not having experienced any darkness for over a year. The amount of little sea shrimp had once again increased. There were quite a lot of them. Just look at them go. After 4 months it seemed like the cyclops had gone extinct. But surprise, surprise, here they are, doing well and reproducing. Maybe they were just hiding at that point in time, or maybe all the adults were actually dead for some reason and some of their eggs hatched after some time. Who knows? I don't. The flatworms were still roaming around in the jar, and the tubifex were still boogieing all night long. Make that all day long. The snails were still active and having babies. And, although they haven't been abundant since their downfall early on, the string algae are still present. I also noticed a lot of these tiny white balls, which I think might be ostracod eggs. So, this is what this jar looked like 4 years and 3.5 months ago. 2 weeks later, 4 months later, and a little over a year later. Well, that's the last you ever saw of this project. From that moment I left you guys in the dark. Before we see what it looks like now, let's see what happened in the meantime. Alright, so I thought I had more footage of this jar than I actually did. This is the only clip I have from about half a year ago. I'll deliver the bad news straight away. The boogie worms are gone. They made it way past the 1 year mark and were in this jar up until quite recently. They made it past 3 years for sure. I could have sworn I filmed them, but I just couldn't find the footage, unfortunately. So, no more tubifacts. What we do see at this point in time, however, are a lot of snails, and quite a few babies too. Due to the constant light, there's a lot of algae and therefore a lot of food for these snails to eat, meaning this jar can support quite a high number of them. At this point there were also still quite a few flatworms. What you're really here for though is to find out what this jar looks like after 4 years and 3.5 months. Hey, that's my line. What you're really here for is to find out what this jar looks like after 4 years and 3.5 months. Well, after 4 years and 3.5 months it looks like this. Wow! Let's look at the inhabitants of this jar. When this jar was a year old, there were still cyclops or copepods in there. That's quite a long time for cyclops to last in a closed ecosystem, in my experience in freshwater ecosystems at least. After over 4 years, there are still copepods in this closed ecosystem. I believe that makes this ecosystem the freshwater ecosystem with the longest lasting cyclops population. Interestingly though, they are very small. The first 2 clips were actually shot through a stereo microscope at 45 times magnification. In the last clip you can see it compared to an ostracod, which are usually the smallest. It also looks like there isn't a large number of them, but they are quite hard to see and find in the first place, so that might not be true. This could mean that it is a different species than the one we mostly saw at the beginning. Not a strange hypothesis. Or it could mean that all the adults died recently and these are just a few young ones left, in which case they would still be copepoded larvae, not fully developed yet. This may seem like a really far-fetched hypothesis, but it is actually exactly what happened with the snail population. Since the start of this experiment, this jar was home to a population of bladder snails, Visa fontinalis, and since they started reproducing, there have always been quite a few of them. Just half a year ago there were many of them. Now, for whatever reason, almost all of them died. At first glance it might look like they went extinct, but that luckily isn't the case. There are still quite a few snails in here, but they're all really young. I hope these babies are able to reach adulthood and reproduce again, otherwise they really will be extinct. You might be wondering what caused all the adult snails to die, and I honestly don't have a clue. As far as I can remember, nothing really noteworthy happened in the last 6 months. All I can say is that ecosystems, closed or not, are really complicated and delicate. Assuming these babies will eventually make babies, we just witnessed a near extinction event for our permanently illuminated jar. Speaking of snails, I think we're seeing the remains of a dead one on screen here. It is the bulge that's being overrun by flatworms. So yes, the flatworms are still here. And in great numbers, I might add. I've been trying to figure out what species they are exactly, but so far have been unsuccessful. It's difficult though, because I can't just grab one and they're difficult to clearly see through the glass. Having said that, I am fairly certain that it is a planaria in the family of Ducheciidae. I am also fairly certain that it belongs to the genus of Duchecia, or maybe Girardia. The latter was actually considered to be a subgenus of Duchecia until 1991. Interestingly, whatever it is, I've never seen it before in any of my projects. We've seen planaria before on this channel, but those were all different species, way larger too. This seems to be quite a small species. The longest one are half a centimeter at most, which for my American audience is almost 1/18,000th of a football field. Hope that helps. One interesting thing I've seen them do, really interesting, is swimming. Luckily I have some footage of it. Usually when they want to go up to the water surface or down again, they take the glass. But I've also seen them move up and down the water column freely. I don't really know how that works exactly. You'd think they would need some structure to cling onto, especially when going up, but I haven't seen anything. They seem to be thriving in this environment, having lived here for many generations. Another little critter you probably already saw zooming around and that's still here is the ostracod. That's right, the little sea shrimp have also been thriving and reproducing in this closed ecosystem. The mysterious white balls we saw earlier are still here, and I still think they're ostracod eggs. If we take a bit of a closer look at the sediment through the stereo microscope, we see that it almost looks like a sort of bubbling soup, buzzing with ostracod activity. Some other things I've noticed include these stripes of algae on the glass, which formed over the last few years and are kinda weird. I don't really know what happened there. And these grazing marks in the algae on the glass. They are the work of the bladder snails. So let's talk about the algae. I haven't seen any multicellular algae, like the string algae, in quite a while. But there are of course still algae in here. Otherwise the ecosystem wouldn't function anymore. There's still microscopic algae in the water column and also some algae growing on the glass. You can actually see that where the LEDs were located, the algae grew more, but the snails also grazed more. So what about the darkness needs of these algae? Don't all plants and algae need darkness to survive? Well, that is a really complicated matter. The short answer is no, not all plants and algae need darkness. Some species do, some species don't. But it also highly depends on the environment, like the concentration of CO2 in the water. Photosynthesis also has a cycle called the dark cycle, but not because it needs to occur in darkness, just because it doesn't require light. It's also somewhat species dependent, I believe, and I don't know which species we have in this jar. Anyway, it's a really complicated but fascinating topic that goes a bit beyond the scope of this video, but just because this ecosystem never sees darkness, it doesn't necessarily mean that all algae will die. What about the animals? Don't they need darkness to sleep? Well, once again, it's a really complicated subject. Very little is actually known about invertebrate sleep. We're not even sure if crustaceans, like the copepods and ostracods, sleep at all, let alone if it's correlated with light. For the snails, it's also complicated. As far as I know, nothing's known about the sleep cycle of our bladder snails specifically. Studies conducted on other freshwater snails showed they have a sleep cycle that is not correlated with light, as its sleep cycle can last between 13 and 96 hours, taking short naps. Interesting to note is that the 8-eyed blood hedgehog is a nighttime predator. Since nighttime never arrived in this jar, it might have stopped hunting as well. It could explain why it's the only animal that did not survive in this ecosystem for several years. As far as the other animals, they have. With the exception of the boogie worms, which went extinct quite recently, all the other animals are still alive in this unique closed ecosystem. They've lived, thrived and reproduced for generations in a very small closed ecosystem for over 4 years. And if that wasn't crazy enough, which it is, this ecosystem has also not experienced any darkness during that time. Truly mind-boggling. Well, consider my mind boggled. What an emotional ride. This has been one of my favorite and most unique experiments. I hope you guys enjoyed it as much as I did. Subscribe if you want to see more. Subscribe if you do not want to see more, just for the fun of it. And sleep well, because these guys won't. Ha 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 ha.